Hey guys, so due to a viewer request, we're going to be talking about graphing linear equations today. So a linear equation is any equation that's of the form y equals mx plus b. This is the general form. Now this doesn't show all possible linear equations, but this shows most linear equations. And I'll say what I mean by that in a second. So this is usually the general form of a line. And this also includes things like y equals 5. Because if you set m equal to 0, then you just have y equals b, or in this case, 5. Now we're also going to see how to graph something like x equals 5. Now this would not be covered in this general form because there's no value of m and b such that you're just left with the equation x equals 5. But it's not too far off from this general form anyway, so we'll still include it. Now there's two strategies for graphing these linear equations. And in some sense, it applies to equations in general. So the first one is you connect the dots. So you know some points, and then you just plot them on your graph, and then you just connect them to form a line. Now the other pattern, or the other strategy, I should say, is you follow the pattern. So this involves you knowing some things about the line. For example, knowing what the m and the b refer to. How do they affect the behavior of the graph? Well, once you know this, as long as you have one starting point, you have all the information you need to draw the rest of the line. This is what we'll do when we're starting out. Since we know that our graph looks like a line, so all we can do is just plot some points and then just connect them with a line. That's the simplest way to do it. This, once we do a little bit more exploring, will be the go-to method. But first, we'll discover how it works using this as ways to generate examples. So first example, using the strategy of connecting the dots, is graph the function or the equation y equals 3. So what this means is, this is graph all points x comma y, where the y coordinate is 3. So let's look at some possible points. So I could graph perhaps this point over here. I could plot it. This is the point 2 comma 3, because I go to the right 2 and then I go up 3. Now I also have, let's say, this point over here, which is 4 comma 3. And I could also do, let's say, this point here, negative 4 comma 3. These are 3 points where the y coordinate is equal to 3. And now all I do is I just connect this with a line. And so in general, whenever you have something of the form y equals 3, it's going to be a horizontal line with that specific y coordinate. So in general, and actually, once you know this fact, you're good, and you can always draw this kind of line. So the next kind of equation we're looking at is x equals 3. So for this equation, let's again do the same thing as before. So let's actually figure out what some points are where the x coordinate equals 3. So remember, I'll just write this down. So the set of all points x comma y where the x coordinate is 3. Well, here's one example, 3 comma 0. Another example would be over here, 3 comma 4. And another example could be here, 3 comma negative 4. And as you realize, any point on this region, or I should say line, is going to have x coordinate 3. So I can connect these 3 dots with a line. Now let's see how this strategy works with a more general example, something that's similar to the more general form that we saw before. So now we have y equals 2x plus 4. And we're going to use that strategy, but we're going to be a little bit more methodical about it. So here's how we're going to generate the points. So step 1 is you pick some value of x, and pick a nice value of x to make your calculations easy. Then what you do is you solve for y. So you plug in your value of x, and then you solve for whatever y value you get. You're not really solving, it's just whatever value you evaluate out to be. And then just rinse and repeat. So do this for maybe 2 points, 3 points, whatever you think is enough so that you can comfortably draw a line. So let's do this let's start with x equals 0 because that's the easiest value to plug in, right? 0 is nice, just makes everything 0. So now we have y equals 2 times 0 plus 4, which is just equal to 4. So the point that we're going to plot is 0, 4. Then let's try x equals 2. So y equals 2 times 2 plus 4, which equals 8. So the point that we end up plotting is 2, 8. And finally, let's try x equals negative 2. So y equals 2 times negative 2 plus 4, which equals 0. So now the point we want to plot is minus 2, 0. So we'll just look at our graph and plot these points. So 0, 4, that would be right here. 2, 8, that would be right here. And negative 2, 0, that's right here. And now you just connect them with a line. And so on. Okay. So now that we've tried this strategy out for a little bit, we have some ideas on how to generalize this for our original equation, the general equation of the line. So this is how we're going to use strategy 2. We need to understand what each part of the equation means. So we need to understand in the equation y equals mx plus b, what is the meaning of m and what is the meaning of b? How does it affect the graph? So the easiest thing is to first look at them separately. So first, we ignore the b and we just look at the equation y equals mx. And we'll try different values of x to figure out how this affects the graph. So when we have m equals 1, for example, well, that would be the equation y equals x. So we can try 3 points. We could plug in x equals 0, x equals 1, x equals 2. And the corresponding y values are 0, 1, and 2. So you can plot these points now. So 0, 0, let's plot that on our graph. Then let's plot 1, 1. And let's plot 2, 2. And let's fit these in with the line. So our line is going to look something like this. Now let's try changing m. So let's make m bigger. Let's see what happens to the graph. So let's do m equals 2. So this is the equation y equals 2x. So again, we can first try by plugging in 0. We get out 0. We can try plugging in 1 for x, and we get y equals 2. Or we could try plugging in negative 1 for x, and we get y equals negative 2. So we can graph these points. So we have 0, 0, 1, 2, that would be over here, and negative 1, negative 2, that would be over here. And now we can fit this with a line. So let's go like this. Okay, so what we start to see is when you make m a little bit bigger, your graph is slanted a bit more. It's a steeper graph, steeper line. So let's try this with, finally, m equals 1/2. That means we're making m smaller, so we should expect the graph will also be, the slope will be a little bit less shallow. So we have, or I should say the graph will be less steep. So we have y equals x over 2. We have x equals 0, y equals 0. When x equals 2, y equals 1. When x equals 4, y equals 2. So let's plot these points again. So we have 0, 0, and then 2, 1, and then 4, 2. So now when we extend this, and we get what we expected. So it's a less steep graph than before. So this is called the slope, and I use this term over here. And the way we'll define the slope officially is it's going to be the rise over the run. And this affects how steep the graph is. So for example, if you move 3 units to the right, and that causes you to go up 4 units, that means your slope is 4 over 3. If, for example, you had only moved 1 unit to the right and shot up 3 units, your slope would be 3 over 1, or 3. Now let's try to understand b, the last term that's unknown in this linear equation. So we have y equals x plus 0, y equals x plus 2, and y equals x plus 4. So I'm basically just testing out different values of b and seeing how they affect the graph. So I've graphed these 3 equations over here. And you can see that as I increase b, my line gets higher and higher. So what this means is b, all it does is it shifts your line up and down. If you decrease b, your line gets lower. If you increase b, your line gets higher. And there's actually a physical location where you can look at the graph and say, okay, this is what b is. And that's where it intersects the y-axis. Because if you notice, where does it intersect the y-axis for the first graph? Well, it intersects it at 0, 0, 0, height of 0. And what do you notice about b? b equals 0. And now let's look at the second graph. It intersects the y-axis at the value y equals 2. And look at the graph. b equals 2. And same thing with the graph over here. It intersects the y-axis at the value 4. So these things match up. So in other words, b is your y-intercept. b corresponds to the y-intercept. So whatever value of b is, you will definitely pass through the point 0, b. So this gives us an idea on how to use strategy number 2, which is you first look at the y-intercept and start over there, and then you just generate the remaining points by looking at the slope. So let's look at an example of that. So we have this equation y equals 1/2 x plus 3. So we'll first start with this value 3. That means it's the y-intercept. So in other words, 0, 3 is on our graph. Well, let's plot 0, 3. That's over here. Now, the 1/2 refers to the rise over run, the slope. So rise over run equals 1 over 2. So that means every time I go 2 spaces to the right, I go 1 space up. 2 units to the right, 1 unit up. So let's generate the points based off of our starting point. So let's say I go 2 spaces to the right and 1 space up. 2 spaces to the right and 1 space up. 2 spaces to the right and one space up. And I can also go backwards. So if I go 2 spaces to the left, then I have to go 1 space down. Now in practice, you wouldn't actually draw all of these points. You would just start with your seed point, and then you would just sort of draw the chunks. Like this. Okay. So this is how you would draw the graph of a linear equation if you can write it in the form y equals mx plus b. All right, so that's all for this video. I hope you guys found this useful. Hit the like button and subscribe to this channel as usual so that you can see more content on a weekly basis. Thank you.